Game makers, today we're going to work on a survival game. It's going to be a mix between Minecraft, V-Rising, Astroneer, and Subnautica. I know what you might be thinking. What does it even mean to have 4 different games all mixed together? From Minecraft, I want to take the core act of mining blocks, having them drop in the ground, and then being able to pick them up again to craft stuff with. From V-Rising, I really like V-Rising's camera angle. That top-down camera angle is really good for strategic, tactical gameplay, not yet often seen in survival games. From Astroneer, well, Astroneer's got this super cool mechanic that I love. In Astroneer, you're out in outer space, so you're short on oxygen all of the time, so you have to stay tethered to an oxygen source. If you want to explore out further, you have to drop tethers along the way. I really love the way that Astroneer pulls those off, so I want to borrow that for our survival game as well. And then the last survival game that we're going to take inspiration from is Subnautica. Subnautica is a great game. It has this awesome underwater vibe. The depths of the ocean are as unknown to us as the far reaches of space. You can see how all of these games are going to fit together. Imagine a mining and crafting game that has a top-down camera angle where you can use tethers to extend out your oxygen for exploration while you explore underwater at the bottom of the sea floor. Let's dive right in. Let's talk about terrain generation. How can we generate a world the player will want to inhabit? Perlin noise is a technique commonly used in games like Minecraft for procedural terrain generation. Perlin noise is a mathematical formula that comes up with different numbers between the value of 0 and 1 along a coordinate grid. So here's a simple grayscale image of Perlin noise in which black corresponds to a value of 0 and white corresponds to 1. One of the unique properties of Perlin noise is that it generates the random values throughout the grid, but adjacent pixels have similar values, so you don't get dramatic changes. To illustrate the uniqueness of Perlin noise, here's a picture of what normal noise looks like. This is an image where every pixel is selected completely at random. And then here you can see Perlin noise has smooth gradients along the grid, so it doesn't have those harsh changes. So when you want to use Perlin noise to generate terrain, one approach is to try and interpret the Perlin noise in different ways. For example, we could say that all the very light areas are valleys and all the dark areas are mountains, and you might get something like this. Another approach would be to treat everything from, say, 0 to 0.5, that's going to be all the darker areas, as forests, and everything from 0.5 to 1 as swamps. And now you have forests and swamps interwoven along the terrain. Another fancy approach would be to pick an intermediate range, let's say everything between 0.4 and 0.6, and we'll call that a swamp. And now you have a network of swamps running through your terrain. We'll use these techniques to build our world in layers. First, we'll use Perlin noise to create iron deposits, then a layer of copper deposits, followed by some seaweed, and then finally, we'll fill in the remaining area with rock. The last thing I'd like to talk about with regards to terrain generation is that rather than using Perlin noise on an orthogonal grid with 90-degree angles, let's use Perlin noise with hexagonal tiles. The nice thing about hexes is it tends to have a more organic feel. A square grid works, but it will feel very rigid because everything is happening at a 90-degree angle. As soon as we shift to hexagonal tiles, it gives the game a more natural and organic vibe. When you make any new game, game developers have what we call the 3 C's: character, controls, and camera. So that first C, character, has to do with who am I? Am I a named character with a backstory? I could be a wandering hero, or I could be a cat. Kind of like that beloved game Stray. Am I an unnamed protagonist? Maybe I'm playing as an avatar that I created, where I got to decide who I am and what I look like. If you think about a simulation game, I'm usually an emperor or an unseen god watching over my creation. The second C is controls. This is sort of like, what can I do in the game? How do I control my character? Can I jump, dash, climb, slide around? Do I have weapons that I can use to attack other people? Can the game be played with a mouse and keyboard? Can it be played with a controller? How about a touch screen or VR controllers? And then the third C is camera. Where is the camera actually going to be positioned? If you're a first-person game, then you're seeing through the eyes of the protagonist. But if you have a third-person game, sometimes the camera is slightly behind the character. With a top-down game, you're seeing the character from above. Straight up, first-person and third-person games tend to feel more majestic and immersive because we as humans have a deeper emotional connection when we can get a sense for the horizon, the height of the environment, and other factors like that. Third-person cameras are going to show off your character the best. So how do you pick? Well, it kind of depends on what kind of game you're making. Choose a camera that supports the emotions that you want to try and convey to the player. Use a first-person camera when you want the player to feel more immersed and have a high sense of presence. Use a third-person camera if you want to show off the character or the character's interactions with the environment. Use a top-down camera when you want the player to feel more safe and for the game to feel a little more strategic. A top-down camera allows the player to be a bit separated from the action, and that can be a good or bad thing depending on the type of game that you're making. So in our case, our survival game is going to be a top-down game. I want to focus on the resource gathering and harvesting elements of a survival game, and being deep underwater is already stressful. Some people might find an underwater game a bit claustrophobic, and by choosing a top-down camera angle, we can increase a subconscious sense of safety. So to go over the 3 C's for the game that we're going to make, for character, we'll have a character named Seymour who's walking around on the seafloor. For controls, we'll target a game controller that lets the player walk around, mine, craft, and build. And then for the third C, camera, we'll go top down. As we're working on the game, the next thing we need to figure out is what are we going to do with all the blocks in the distance? See, in a top-down camera angle, you can see all this extra stuff off to the edges, and that's no good. In a first-person perspective game, you don't normally have to worry about this because the closer geometry is automatically obscuring the farther away geometry. But in a top-down game, you don't want the player to be able to essentially see through walls. And so you have to do something to hide stuff that's in the distance. It's a problem that's unique to top-down games. So a naive approach would be to simply just not draw those faraway objects. But that results in the environment looking kind of abstract. A tech artist on the team I was working on figured out that you could actually edit the rendering so that the areas far out could be rendered as black. And then around the edges of each block that's been generated, we would just have some sort of this unknown geometry wall along the edges, and that blends into the blackness that creates this really nice effect of not being able to know what's beyond the edge of the map. With the resources all settled out, let's talk about what it's like to actually have resources that you can mine in a survival game. Consider a game like Minecraft. In Minecraft, you've got resources like cobblestone, and then the cobblestone gets mined as a block from the world, and then after you mine it, it turns into a small block that floats out and can be picked up. And then when you step on it, you pick it up and it becomes cobblestone in your inventory. Now from the player's point of view, it's just cobblestone in the world, cobblestone on the ground, and then cobblestone in your inventory. It's cobblestone all the way around. And that's great for the player, but from the designer's point of view, it's actually 3 different states that the item can be. There's the 3 distinct states that we want to be thinking about. Why is it useful as a game developer to think about cobblestone going through all these different states? Well, a lot of your resources are going to go through these states. Sand will be sand in the world, and then sand on the ground, and then sand in the inventory. Wood would do the same thing. World, ground, inventory. But then once you have those 3 states, you can start to play around with it and do some pretty cool things. You could have normal stone that when it's broken turns into cobblestone, and then it becomes part of the cobblestone loop. You could have gravel that normally turns into gravel, but 1 in 8 times it turns into flint instead. That's literally what Minecraft does. You could have glass, which is a glass item when it's in your hand, and then when you place it in the world, it's glass in the world, and that's great. But then when you break it, it just gets destroyed completely. And so we'll capture these 3 states in our survival game as well. We're going to have a notion of a geo for the object. That's the geometry of the object when it's actually ready to be mined out of the world. We're going to create another state called the in-world item. And that's what the item's going to look like when it's floating around in the world ready to be picked up. And then we'll have a third state, which is the item in your inventory, just like Minecraft. And then we'll be able to do these same sorts of cool interactions. This is a great framework for any survival game that you might want to make. Shifting gears a little bit, an area of game design that's often overlooked is the importance of using visual and audio feedback to let the players know how the game works. Suppose your game has a rule that a hand crank supplies power to an iron press that turns iron into iron sheets. Seems pretty simple, right? But even this simple interaction won't be fun for the player unless ample amounts of visual feedback let the player know exactly what's going on. Here's an early shot of our hand crank powering an iron press to turn iron into iron sheets. All of the functionality is there, but without any visual feedback, there's just no way for the player to know what's going on. A line from the hand crank to the iron press, it establishes the visual connection, but it's still not enough. Now, if we have the top of the hand crank turn and put a progress bar over the iron press, now we're starting to establish a visual connection with animation that helps the player understand the mechanic of how the game works. Animating the power line between the two gives the player even more feedback, and we can tie it all together with a sound effect that activates only while the power is being transferred. These changes can make the difference between a game that's a frustrating mess and satisfying fun. Every clank, splash, and ambient sound not only immerses players into our underwater world, but also supports the game mechanics, making them feel tangible and rewarding. Shout out to Pandan, who did all the art for the game, and Drazen on audio and music. I'll have a link to the web playable version in the description below. This isometric game took place in the depths of the ocean. In a previous video, I worked with Twitch chat to create an isometric game that lets the player defend a priestess against incoming zombies. I did a full video breakdown, complete with design lessons, which you can watch here. Making games is hard, but you can do it. Thanks for joining me, and happy game making.